So we are getting close to finishing this example set for Unit 7. I'm going to do questions 15 through 17 where you are supposed to solve for x. And I'll see if I can do them fairly quickly. I don't think any of them is going to give us horrible problems or anything. Let's look at number 15 here. So we're adding two things, and they're equal to this other thing. In order to add two fractions, we need a common denominator. So really what I need is a common denominator for all three of these. I see that they all have at least an x, if not an x squared. This has a 5. These do not. So here's what I'm thinking. I could multiply x squared by 5 to get 5x squared. And whatever you multiply the bottom by, you multiply the top by. And I could multiply x by 5x to get 5x squared. And whatever you multiply the bottom by, multiply the top by. And then over here, I don't need to multiply anything because it's already over 5x squared. So let's do that. 5 times 1 is 5 over 5x squared, plus 5x times 1 is 5x over 5x squared, and that equals 4 over 5x squared. And here's the cool part. All of these fractions have the same denominator. So there's a couple ways that I could prove that this is true, but ultimately what that means is these denominators are no longer important. One way to get rid of them would be multiply both sides by 5x squared. Ultimately, when all the denominators are the same, they get eliminated. And what we have is 5 plus 5x equals 4. And I can solve this by subtracting 5 from both sides. So I get 5x equals -1, and then dividing everything by 5. So x equals -1/5, or if you like, -0.2. Either of those is a-okay. I'm going to do the same thing on number 16. This is 5x squared, this is just x squared, and this is 2x squared. So I've got x squareds for all of them. That's good, but the numbers are different. And I'm thinking 10 is a number that is divisible by both 5 and 2. So I would multiply 5 by 2 to get 10. So I'm going to multiply the top by 2 as well. I would multiply x squared by 10 to get 10x squared. So I'll multiply the top by 10. And then I will multiply 2x squared by 5 to get 10x squared. And of course, I'll multiply the top by that as well. So let's distribute here. We get 2x plus 8 over 10x squared plus 10 over 10x squared equals 5x plus 15 over 10x squared. And once again, if they're all the same denominator, then the denominators cancel. And what I'm left with is 2x plus 8 plus 10 equals 5x plus 15. And if I combine some like terms here, I can put 8 and 10 together. So I get 2x plus 18 equals 5x plus 15. From here, I just need to solve it. So I'm going to subtract 2x from both sides. I get 18 equals 3x plus 15. Then I will subtract 15 from both sides. And what I get is 3 equals 3x. And that's going to be beautiful because I need to divide both sides by 3. That tells me 1 equals x. All right. One more problem, and then this video will be done. Let's look at number 17. Now, I love number 17. And the reason for that is the first time I tried to do a problem just like 17, I took the very long way around. I found a common denominator for the two. I combined these. I did a whole bunch of other things, and it took a long time. And then I had a teacher, much smarter than myself, say, well, why don't you just subtract 2 from both sides first? So 30 over x plus 1, whoops, that is just not pretty, over x plus 1 will equal 3. And I thought that's a great idea. That narrows some things down, and even better, if I make 3 into a fraction by putting it over 1, I now have a proportion, and I don't need a common denominator. So it saved me a lot of time and effort. So I'll cross multiply here. I get 3 times x plus 1 will equal 1 times 30. So I'll distribute the 3. I get 3x plus 3. And then over here I distribute the 1 and I get 30. I can subtract 3 from both sides. I get 3x equals 27. And I divide both sides by 3. That gives me x equals 9. I love that problem. All right, I'll see you later.